Hello students, welcome to Mathematics in Action lesson number 4. Now, when we are through exploring, you will be able to 1. Name and measure regions, 2. Compute the area of regions shaped as rectangles and right-angled triangles, and 3. Solve problems involving area measures. Now here is the challenge for you. Can you determine the area of a shape by using a rectangular grid? Let us take a look at the shapes. What are the names of the shapes?
Let's see. Well, this is a triangle and a right-angled triangle to be exact. At a glance, this looks like a square. If the length and the width are the same dimension, it is definitely a square. Let's check. First, the length. Let's see how many units make up the length. 1, 2, 3, 4, 5, 6, 7. That's 7 units for length. Now for the width. 1, 2, 3, 4, 5, 6, 7. Yes, the length and the width are equal, so it is a square.
Very good. Here are some more questions for you to think about. How many unit squares does each shape contain?
Let's see. For the square, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 49. 49 unit squares. Now for the triangle. Well, some of the unit squares are cut in halves, making them little triangles. Alright, I will count the squares first, and then I will count the halves. Here goes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Now for the halves. So that's 21 and a half, 22, 22 and a half, 23, 23 and a half, 24, 24 and a half. So that's 24 and a half unit squares for the triangle.
You have done an excellent job. Do you know what the total unit squares are called?
It's called area.
Very good. Here are some more questions for you to think about. Apart from counting, were there any other methods that could be used to determine the area of the shapes? What did you notice about the area of the square versus the area of the right-angled triangle? Can you derive a formula to compute the area of each shape? How do you arrive at your formula to compute the area of each shape? Did you realize that the area of the right-angled triangle is a half of the area of the square? If you did, very good. The area of the square can be found by multiplying the length times the width. And the area of the triangle can be found by multiplying a half times the base times the perpendicular height. Now students, let us explore a bit further. Do you think it is possible for you to use the same formula for right-angled triangles to compute the area for non-right-angled triangles? How could we use the same formula for right-angled triangles to compute the area of a non-right-angled triangle? Let's look at this. Here is a non-right-angled triangle on a grid. If you fill around the original non-right-angled triangle along its vertices, it will form a rectangle. Please note that the perpendicular height of the triangle is 4 units and its base is 6 units. The area of the resulting rectangle can be found by multiplying the length times the width. The area is 24 unit squares. Let's look at this. Now, what fraction of the rectangle is the yellow triangle? Yes, it would be a half of the rectangle. You would have realized that the two red triangles completely overlay the yellow triangle, which means they have the same area. So, the yellow triangle is half the area of the rectangle. So, the area of the yellow triangle is 12 squared units. Now that you know how to find the area of triangles, squares and rectangles, you can name and measure regions, compute the area of regions shaped as rectangles and right-angled triangles, and solve problems involving area measures. And remember, have fun while putting mathematics in action.